So Unit 7, Day 3. Trig ratios. Trig ratios on a plane. Well, the trig ratios, that's the SOHCAHTOA stuff. So hopefully we know that. A plane, not like an airplane, but like the XY plane. So you know both of those things pretty well. You know the x-axis and the y-axis and quadrants and that kind of thing. You're pretty good at SOHCAHTOA, even though we've only done a couple days of it. It's pretty straightforward. Today we're going to kind of merge those two ideas. And there's 3 Roman numerals today, and today's notes are, instead of just one page front and back, it's one page front and back and then another one page, so 50% longer than yesterday. Roman numeral 1, 6 trig ratios given a point. 6 trig ratios given a point. Up until now, the trig ratios were all in a triangle. Now we're talking about trig ratios at a point. Well, we're going to tie the two together and make it a triangle. It's the short answer of what's going to go on. Step 1 will be plot the point. You know what? Let's do these steps as we go. So let's say there's our point, x comma y. Maybe it's 3, 4, maybe it's 5, 12, who knows? Might not even be in the first quadrant. But there's our point. Plot the point. I mean, that makes sense. The next two are the important ones. Connect the point to the origin. Basically, we're going to turn the point into a triangle and then use SOHCAHTOA. So we're going to force the point to fit what we know how to do, and then we can do it without problem. So connect the point to the origin. That makes the hypotenuse. I think that makes sense. The next one is the super important one. Connect the point to the, here's where you got to get it right. Like you probably would plot the point, you'd probably connect it to the origin because that makes the hypotenuse. The next one is really tricky. It's not tricky, you just got to know which way to go, because you could connect that to the x-axis and make a triangle, or you could connect it to the y-axis and make a triangle. But only one of them is correct. You're always, always, always going to connect it to the x-axis. And that will make our triangle. And then, lastly, theta is at the origin. So some people will mess up and put theta in that far corner, and then that messes up who's opposite and adjacent. So theta at the origin. So let's see, this distance, if our point is xy, we went over x and up y to get to the point. So xy are the two sides of two of the legs of the right triangle. And the hypotenuse we call r. I guess we'll learn tomorrow why we really call it r. R for radius. And r is square root of x squared plus y squared. But now we're ready to do SOHCAHTOA. So we turned it into, we took it from a point, made it a triangle, and now we can use what we already know. So let's just list out the three main trig ratios. The other three we can just get by doing the flips. So sine of theta is opposite over hypotenuse. What is that in my picture? What's opposite over hypotenuse in that picture? Y over r. So cosine is adjacent over hypotenuse. So that would be x over r. Tangent, TOA, opposite over adjacent. Opposite over adjacent. Y over x. Alright, some people will memorize sort of the new set of ratios, y over r, x over r, y over x. I think most students don't memorize those, they just stick with SOHCAHTOA. And as long as you made the triangle correctly, SOHCAHTOA will work. So most people go with that. They don't memorize a new set of ratios. It's like, I already know SOHCAHTOA, that works for me, I will use that, so that's fine. Just be careful, you've got to have your angle at the origin, and you've got to make sure you connected it to the x-axis. That's what makes SOHCAHTOA work. I have down here to remind you that there are some special right triangles that show up. I think we saw 3, 4, 5 already. 5, 12, 13, 8, 15, 17. If you know those, it makes life a little quicker, a little easier. If you don't, then you got to do a squared plus b squared equals c squared, and you get there eventually. All right, well, let's start with an easy one. Let's find the 6 trig ratios through 3, 4. And the 6 trig ratios through 3, 4. Again, this is a little bit weird or different because up till now trig ratios have gone with triangles. Now we're talking about trig ratios through a point. Let's plot 3, 4. And again, basically we're turning our point into a triangle, and then we'll just use SOHCAHTOA. So we connect it to the origin just to make the hypotenuse, or to make the r. Now, do I want to connect it to the x-axis or the y-axis to finish the triangle? Always, always, always x. Even when it's closer to y, you're like, oh, we're right there. Always, always, always connect it to the x. So now we made a triangle. Theta is always at the origin. And you can do a squared plus b squared equals c squared if you need to. But hopefully people recognize that's a 3, 4, 5.
Why is it always the x? Wouldn't it technically do the same? Or is there like a
So if you put it to the y, and you put theta down here, then opposite is 3 rather than opposite being 4. So it forces opposite to be y if you'll draw it to the x. And then everything works. I mean, I don't even want to say it. There's ways to do it to the y, but everything's backwards. And so then you got to figure out, well, which set am I using? So draw it to the x and you'll always be good. Okay, sine, cosine, tangent. And this is the first one, so I'm going to overkill this one. Most of you would probably not write much more than the answer. And so if you want to answer these now, that's fine, but I'm going to remind myself that sine is opposite over hypotenuse, which is y over r. which is 4 over 5. I suspect, I hope even, that most of you would just write sine of theta is 4/5. Because you know it's opposite over hypotenuse. You look at the opposite, you look at the hypotenuse. Like, you're familiar enough with it now where you don't need to write it all out. Same thing with cosine. In fact, just tell me, what's the cosine? Looking at that triangle, what's the cosine of that angle? 3 over 5. So if you're comfortable with that, you can just write 3 over 5. I'm going to write it out just because it's our first one. So ca, which is x over r, which is 3 over 5. How about the tangent of that angle? Just give me the answer. What's the tangent of that angle? 4 over 3. Because tangent is opposite over adjacent, which is y over x, which is 4 over 3. And then the other 3, again, you don't memorize those ratios at all. You just know who the partners are. So who is partners with sine?
The one that starts with the S, right?
Not the one that starts with an S.
CSC.
CSC, cosecant. And then I'm not worried about x's, r's, opposites, adjacent. I'm just flipping sine. 5/4. I don't even have to think about it. Cosecant, or excuse me, cosine goes with secant. And same thing. I'm not worried about any of those letters. I'm just flipping cosine over.
So you want us to write that, though, right? You want us to write the other one?
Yes, because it asks for these 6 trig ratios.
No, yeah, like I'm saying, I wrote them. I just didn't write the
All of this stuff?
No, I didn't write the cot, SEC. I didn't write that. I just wrote what it is.
But I wouldn't know. How would I know which ones those are if I just?
So you do what it
Yeah. So you got to write out which ones they are. Now it's a multiple choice test mostly, so it'll maybe just ask for 1 or 2, or those will be there. So that really won't be an issue, I don't think. Okay, so you know SOHCAHTOA, you know it pretty well. You're just applying that in a little bit different spot. Let's find, let's save a little time. Let's just find the 3 trig ratios. Because if you can find the first 3, then finding the second 3 is easy. For -3, 5. Okay, so negatives, that's the trick for this one. -3, 5. Okay, well, plot the point. There's -3, 5. Okay, now I want to make a triangle out of that. So what should I connect to that point to first? The origin. Okay, everybody gets that right because like you got to have a hypotenuse of your triangle, so that's fine. And then where do I want to connect it to next? Always, always, always the x-axis. And I've given 2 examples that are closer to the y-axis because that's when students are tempted to be like, oh, it's just right there, let's take the shorter path. No, always, always, always to the x-axis. So let's label our triangle. Now's where things are getting a little weird because there's a triangle and we labeled the side -3, which feels a little strange because you can't have a triangle. Like you can't draw a triangle with a side that's -3. So that's where things are starting to get a little funny here. The angle that we would draw, it's at the origin, but I was a little murky earlier. It's not in the triangle, it's always from the x-axis. So the theta we're talking about is right there, which is weird. So yes, Noah, that's a good face to make for that because, like, wait a minute, that's not even in the triangle. What are we doing here? But the theta is always going to be measured from the x-axis. So the x-axis is the important one, right? We draw it to the x-axis and then we measure from the x-axis. But everything else is still the same. We're still going to do SOHCAHTOA. Actually, before I do SOHCAHTOA, what do I need to find? The R. Is this a 3, 4, 5 triangle?
No.
No. Good. So negative 3 squared plus 5 squared equals R squared. So we got us a strange R. That's okay. Square root of 34. Okay, sine, cosine, tangent. Sine we usually think of as opposite over hypotenuse. And this is where things get a little bit weird with SO and CA and TOA, because if you're thinking opposite of this angle, like there's nothing opposite that angle. But we said opposite was always the y. So SOHCAHTOA breaks down a little bit here because there is no opposite that angle. But if you had to guess one of the sides, you'd probably pick 5. I hope you'd pick 5. And then we need to fix that. 5 root 34 over 34. Cosine is adjacent over hypotenuse. And kind of the same thing. There's not really an adjacent to that angle where we drew it. But adjacent always goes with x. So negative 3 over root 34. Tangent is opposite over adjacent. And again, if we're strictly looking at that angle, there is no opposite, there is no adjacent. But we would hopefully figure out that, or remember that opposite over adjacent is the same as y over x. So 5 over negative 3, or negative 5/3. Here's how other people do it. The x is always the adjacent, the y is always the opposite. They're in alphabetical order, if that helps. X comes before y, A comes before O. And so some people, I hesitate to say this because some people are going to do this, and it's fine, it's right, it gets you the right answer. It just doesn't, it's not as visually helpful. They'll label these not so much as x comma y, but right at the get-go, label that A comma O. And then you kind of don't even need the picture because you know who opposite and adjacent are. You still need to find R, but you know that that's got to be x squared plus y squared. So you can work these without the picture. I don't really like that because it sort of loses the understanding of what's going on. But if you're trying to get through quick, instead of thinking that as x comma y, I mean, it's still x comma y, but it's also A comma O, and then you can do your ratios without even looking at the picture. So that's sort of the shortcut. But it's one of those shortcuts where if you use the shortcut too much, you might, forget why it works and what's going on. So that's one where I hesitate to even show the shortcut. Right. Let's talk about signs by quadrant. Signs S-I-G-N-S, meaning plus minus, not sines versus cosines, signs. So sine of theta is opposite over hypotenuse, but that's y over r. This is important. R is always positive. Our hypotenuse is always positive. that'll change midway through next semester, but we're not worried about that right now. R is always positive. So if R is always positive, then the sign of sine, the SIGN of SIN, whether sine of theta is positive or negative, depends on the y. Well, y is positive on the up stuff and negative on the down stuff, right? Because y is an up and down thing. So now that tells us this. This is the weird one because you keep saying sine of sine. SIGN of SIN, the plus minus of sine. It's positive on the up, negative on the down, because sine goes with y. Cosine, so ca, but a goes with x. So cosine is sort of an x thing. So where is cosine positive? If cosine is an x thing, it's positive on the right and negative on the left. So sine goes with y. In fact, this will help later if you remember this. Cosine goes with x. In fact, that's true in physics, right? If you use that in physics enough, you discovered that the x value, cosine and x are sort of tied together. Sine and y are tied together. True in physics, true in pre-cal. Tangent of theta, opposite over adjacent, y over x. Okay, this one's a little bit trickier because it has both of them. So I've got to think about y and x. Oops, I should have labeled that last picture. Sines of cosine. So this one we better slow down a little bit. In quadrant 1, everybody's positive, so I'm not worried about that. In quadrant 2, let's see, y over x is positive over negative. So that equals a negative. Quadrant 3, what's going on in quadrant 3? It's a negative divided by a negative, which is a positive. So tangent's a little bit weird. It's one of those two negatives make a positive thing.
I don't understand. What is positive and negative? What they you were saying?
Because tangent is y over x, and in the third quadrant, the y is negative, and the x is negative. So negative divided by negative, you're going to get a positive answer if you're in the third quadrant.
Oh, okay. Okay, Mark.
And in the fourth quadrant, let's see, x is positive, but y is negative, so you end up with a negative. Okay, here's another shortcut that some people use, some people don't. Some people, it's easy enough for them to think, well, sine goes with y, so if it's up, it's positive. Cosine goes with x, so if it's right, it's positive. And that's fine, and tangent, you got to think about the ratio. But there is this little shortcut thing. And the shortcut tells you who is positive in which quadrant. ASTC, which stands for all students. This is not a true statement, but it makes sense for us. All students take calculus. No, they don't. Of course they don't. But all students take calculus. So who's positive? In the first quadrant, all of them are positive. In the second quadrant, who's positive? sine. In the third quadrant, take t for tangent. And in the fourth quadrant, C for calculus or C for cosine. All students take calculus. Tells you who's positive. I will see that picture on test for the rest of the year, because we use this the rest of the year. And so a lot of students, every test from here on out, like as soon as I hand it out, they draw that and they're ready to go. So it's a pretty quick and easy little device to help you remember who's positive where. Make sure you go in order. All students take calculus, and from there it's pretty easy. Questions on that? The other method is, I don't need to memorize that. I know that sine is a y thing, so it's positive on the up. Cosine's a x thing, so it's positive on the right. And tangent is the ratio, so it's positive on first and third. So either way. Roman numeral 2. Reference angles. Reference angle is the smallest angle to the nearest, here we go again, the nearest x-axis. We love us some x-axis today. Draw the triangle to the x-axis, measure the angle from the x-axis, and measure the reference angle to the x-axis. Reference angles are always positive, so you don't have to worry about, well, like, did I rotate forward or backwards? Like, nah, it doesn't matter. Just get to the x-axis. And reference angles matter later, so it feels like, what is the point of a reference angle? It's like, well, hold on. It's one of the building blocks that we'll use later. So let's find the reference angle for theta equals 27 degrees. Let's see, so 27 degrees, that would be in the first quadrant. That would be something like that. That's 27. If you're thinking you know the answer and you think it feels easy, you're right on this one. So what's the angle to the nearest x-axis? 27. So that's kind of dumb. It's just the same as the angle. Well, it is for that one. But if theta equals 95, what quadrant would that land in? A second quadrant, because that's a little bit more than 90. Okay, so what's the nearest x-axis for that guy? Okay, so this is the nearest x-axis that we're headed toward, but what's this angle? 85, because it was 180 minus 95. But the formulas all kind of change and are different, so I would not memorize 180 minus, because that's not really it. That only works some of the time. It's better to just look at the picture and figure it out. Theta equals 253 degrees. Well, first would be, what quadrant does that land in? The third one, because what's this down marker here? 270. So 253 is a little shy of 270. So my reference angle, like the closest x-axis is 180. So how far is it to 180? 250,
Three or no?
whatever 253 minus 180 is, 73. So there is a formula way to do reference angles, but you'd have to memorize a different formula for each quadrant. And so that gets a little annoying when really all you need to do is just figure out how far away from the closest x-axis are you. Now, what makes it a little trickier is when we're in radians. So we're going to do a second set of reference angles. But let's draw the full circle with radian measures on it. So 0 and 2 pi, start at 0, 2 pi's all the way around. Halfway around would be pi. Pi over 2 would be halfway between 0 and pi. And then what's between pi and 2 pi? Like the down marker over here. Okay? That's not how we usually say it, but that's absolutely right. Pi 1.5. Fair enough. 1.5 pi sounds a little bit better. Both of those are correct, but you will always see it written as 3 pi over 2. But you're right, that is pi 1.5. Or 1.5 pi. So let's see if theta equals 13 pi over 12. This is where our fluency with fractions, how comfortable we are with fractions, comes into play. Because we got to know what quadrant 13 pi over 12 lands in. The third one. How'd you know that? Perfect. That's the perfect answer. 13 over 12 is a little over 1. I know 1 pi is right there. So my picture doesn't have to be perfect. It's a little past 1. So there we go. 13 pi over 12. In fact, little over 1, how much over 1 is the reference angle? So how much past 1 is it? 1/12 past 1. So our reference angle is pi over 12. So the difficulty for reference angles in radians is more about fraction ability than anything else. (13 pi over 7). 13 pi over 7. Where would that land us? And sometimes it's helpful to label the quadrant markers here. 13 over 7. So it's definitely bigger than 1.
I think it's almost in the fourth. It is in the fourth.
Why do you say it's in the fourth?
Well, it's almost 2, right?
That's the perfect way to say it. It's almost 2. Like 1 and 2 are your primary markers here because those are the x-axis. So if you can think about that fraction in terms of 1 or 2, you'll be pretty good. So is it a little more than 1, a little less than 1? Is it almost 2? Yeah, and that one's almost 2. So we're in the third quadrant. Or excuse me, fourth quadrant. Fourth quadrant. Almost 2. In fact, how much shy of 2 are we? Because that would be the reference angle. Yeah, we're a seventh shy of 2 pi because 14 over 7 would get us to 2. So our reference angle is pi over 7. Again, it's fractions more than anything. 13 over 7 is almost 2. 1 more seventh and you'd be at 14 sevenths. So you're 1/7 shy, so your reference angle is pi over 7. All right, let's really muddy the waters and go with negative 3 pi over 4. What's the negative mean? It does matter because the negative means you're going backwards.
I thought you said it doesn't matter. What does it not matter?
It doesn't matter in terms of what the reference angle is, but it does matter in terms of where this original angle is. So I need to back up 3/4 pi. So if I'm backing up, what's that? What quadrant will it land in? Do you know? Okay, be careful. 3 pi over 4 is in the second quadrant, but that's if we're going forward. If we're going backwards, it's going to land in the third because it's bigger than a half.
Oh, okay.
Right? We're going backwards, so everything is just out of whack on this.
Wait, so it's even on.
Reference angle?
Wait, why is it not 3 pi over 2 at the bottom?
Well, it is. 3 pi over 2 and negative pi over 2 are coterminal from yesterday's. But I didn't want to label it as 3 pi over 2. I wanted to label it as negative pi over 2 because I'm trying to think backwards. You kind of flipped them. So now the top is negative 3 pi over 2 because we're going backwards. It's still 3 pi over 2 at the bottom. You're right. But negative pi over 2 is the same place. So how far are we from the x-axis? How far are we from 1? Pi over 4. Okay, we won't have much time, but we need to do a couple of puzzle problems. Kind of put it all together. Some of you are going to like these. Some of you are going to, your brain's going to be exploding here. So I hope we got more likes than explosions. If tangent of theta equals negative 4/3 and sine of theta is less than 0, then theta is in quadrant. What quadrant is theta in is the question. Tangent is negative, sine is negative. So let's think about this here. If tangent is negative, this is where sometimes all students take calculus. Helps. If tangent is negative, where does that happen? I got a third and a fourth. Not the third. Tangent's positive in the third. So it can't be in the third quadrant. Definitely can't be in the first quadrant. Tangent is negative in the fourth or second. I don't know which one. But that's why it gives me some more information here. Sine is negative. Where is the sine negative? Yeah, so sine's negative in the bottom. That's a good way to say it. Sine goes with y, so it's negative in the bottom. It's positive in the top. So which quadrant meets both criteria? Got to be quadrant 4. Which one sort of meets both criteria? Skip to the last example here. Cosine is negative 1/2, and tangent of theta is greater than 0. Draw the triangle. Cosine is negative. I'm not worried about the 1/2 yet. I've got to figure out where this is first. So where's cosine negative? How about just second and third? Everybody's positive in the first. The left is the best answer because cosine goes with x, so it's negative on the left. That is the best way to think of it, and that's really going to help later if you think of it that way. Cosine goes with x, so it's negative on the left. So I'm definitely out on the first two quadrants. I'm in the second or third. I don't know which one yet. I also know that the tangent is positive, though. Where does that happen?
In the bottom.
That happens in the third and the first, but I already threw out the first. So I know I'm in the third quadrant. But I mean, that's part of my answer, I guess, but that's not what the question asked. The question said draw the triangle. Cosine is -1/2. Now I'll use those values. What was cosine and what was the ratio for it? Okay, good. You're still thinking so ka toa, not x's and r's, which is fine. So adjacent is the x value. Hypotenuse is the r. And then I just need that missing side. But that looks like an a squared plus b squared equals c squared thing. It's not 1, right? 1, 1, 2 wouldn't be a triangle. 4 minus 1 would be 3. So it's the square root of 3. Except that it's not the square root of 3. Look at the picture. Why is it not positive square root of 3? So what is it? Negative. So you got to be careful. That's a big thing. Is like you got to look at the picture. You can't just use the formula there.
So is that 2 also negative?
No, the r is never negative. Good question. The r is never negative, or the hypotenuse is never negative. All right. So worksheet 3. There's a lot of stuff going on, but many of you sound like you got it figured out.